Hi everyone. Today we're going to be talking about adding and subtracting polynomials by applying the distributive property and or combining like terms. So if we look at this page, it says, using your prior knowledge of expressions and equations, can you describe the following vocabulary words? So if we look at the first word, we see it says monomial. Mono means one. So 3x is considered a monomial or one term. A binomial, bi means two, stands for two terms. So x plus 7 is a binomial. Terms are separated by pluses and minuses. So anytime you see a plus sign or a minus sign in between, it's separating terms. So x is one term, 7 is a second term. If I look at the third one, a trinomial. Tri means three, so a trinomial is made up of three terms. Again, separated by pluses in this example. Here's term number 1, term number 2, and term number 3. And then finally, a polynomial is an expression made up of many terms. It would be anything that's more than 3. So in this case, we have one term, 7x squared is one term, 3y is two terms, the third term is 2x, and then we have a 7 at the end. So again, terms are separated by pluses and minuses. So if we look at this expression, this is an example of adding polynomials. 4x minus 2 plus 3x minus 5. So if I look at what's modeled here, you see on the bottom, the blue square represents an x squared, the green tile represents an x, yellow chips represent a positive, and red chips represent a negative. So first I'm going to model 4x minus 2. So if I look below, I see 4 x's, and I see 2 red chips, which represents the negative 2. For the second set of parentheses, I see 3 x's, and I see 5 red chips. So because I'm adding these together, I'm combining them, I'm going to put my chips together to see how many I have. Well, if I combine the x's with the other x's, I have 7x. 4x plus 3x gives me 7x. Now, if I look at my red chips, they would combine together. I have a negative 2 and I have a negative 5, which means altogether I have 7 negatives. So all I'm going to do is put my two terms together, 7x minus 7. If I want to represent this mathematically, 4x minus 2 plus 3x minus 5. So if you're not going to model with the tiles every time you solve a problem, what you're going to do is after the addition sign, you're going to put an imaginary 1. And what we're going to do is distribute this positive 1 to both terms. So the first term stays the same, or the first set of parentheses stays the same. I'm just going to drop the parentheses. So 4x minus 2, a positive 1 times a 3x is a positive 3x. So I'm going to write that as positive 3x or plus 3x. A positive 1 times a negative 5 is a negative 5. So I'm going to add that to the end of my expression. So now I removed the parentheses and I'm going to combine like terms. So I know 4x combines with the positive 3x. Now remember, I'm always keeping the sign in front of the number. So 4x plus 3x is equal to 7x. I'm going to use a different shape to represent a different set of like terms, negative 2 and a negative 5. I put them together on the side, and I know from Unit 1, using the battle method, these combine together, they're on the same team, and there's 7 soldiers. Now all I'm going to do is put my two terms together. 7x minus 7, which is my final answer. And that's exactly what we modeled here using the algebra tiles. So let's try another one mathematically without any tiles. Again, I see that plus sign, so I'm going to put an imaginary 1 in between. I'm going to drop the parentheses in the first part of the expression, 3x plus 4. I'm going to distribute out a positive 1. 1 times 6x is a positive 6x. 1 times a positive 9 is a positive 9. Now I'm going to use the shape method to combine like terms, 3x, and I keep the sign in front of the number. So I write on the side 3x plus 6x, which equals 9x. I'm going to use a different shape to combine the other set of like terms. 4 plus 9 is equal to 13. And now I'm just going to put these together. 9x, and since this is a positive 13, I'm going to write plus 13. And my final answer is 9x plus 13. So there's nothing else for me to combine, so this expression is in simplest form. Now, when we get to subtracting polynomials, this one is a little bit different. Same concept, we're going to put in the imaginary 1. We're going to keep the first set of parentheses exactly the same. 5x plus 3. I drop the parentheses, and now I'm going to distribute out this negative 1 to both terms. Negative 1 times a positive 2x is a negative 2x. A negative 1 times a positive 7 is a negative 7. So this is my new expression after I complete the distributive property. I'm going to combine like terms, and you guys can see this all down here as well. 5x minus 2x. On the side, I write 5x minus 2x, which is equal to 3x. And then I use a different shape for the other set of like terms, 3 minus 7. When I combine these together, I get a negative 4. Now again, I'm going to take my two answers and put them together. 3x, and the way I determine the operation is based on the sign of the next answer. It's a negative 4, so I'm writing negative 4 or minus 4. And my final answer is 3x minus 4. We try another example. So again, subtracting polynomials. I'm going to add in that imaginary 1. I keep the first set of parentheses exactly the same. I distribute the negative 1 out to both terms in the second set of parentheses. Negative 1 times 3x is a negative 3x. Negative 1 times a positive 8 is a negative 8. And now I'm going to combine like terms. 6x minus 3x, I write this on the side. 6x minus 3x is equal to 3x. Positive 4 combines with a negative 8. 4 minus 8 is equal to, again, if I remember battle method from Unit 1, what team would win? The negatives by how many soldiers? 4 of them. I put my answer together, and I actually end up getting the same answer I did to the previous problem, coincidentally. So my final answer is 3x minus 4.